Okay, hi everyone. Today I wanted to give you a quick tutorial about how to build procedural surface imperfections in Blender. And this also gives us an opportunity to talk about how to construct masks with material nodes and how to make use of them. So we'll be aiming to make the result I've got on the right here. It may not be exactly one-to-one by the end, but we'll just take the opportunity to learn a few things and have a little chat. So first of all, I'm going to clear off all I've got here and then we can get started. Alright, so I've got a basic sphere here on the right, and it's basically just using the glossy BSDF shader. And the reason I'm using this one is because I think it looks really good for metal objects. As well as that, I've got an emission shader above here, and I'll explain why these are useful in a second. We're not going to be using the Node Wrangler add-on, we're just going to be doing everything manually. So when it comes to building procedural effects, we're going to be making use of generated noise textures, which I'm sure all of you are familiar with to some degree. The one texture that seems to have more power than any else for building complex and really realistic effects is the Musgrave generated texture. So I'm going to go ahead and add one of these. And what we can do to immediately see the result on the surface of the sphere is just to plug the height value into the color. And here we'll be able to see the white to black range. Now when building up procedural masks for materials, using the emission shader is really handy for getting the clear, accurate values. So just to give you a demonstration here, if I plug the emission in, there we go, we've got a much better representation because with emission, it's not taking consideration to any of the surrounding light in the scene when presenting the blacks and whites. So you can see as I flick between these, we're getting a more accurate representation from the emission. Now the basic result of Musgrave, as you can see, is quite boring. I mean, it doesn't look like any kind of imperfection whatsoever. So what we'll need to do to make the result more interesting is of course play with the values to try and get something that's more realistic. Now Musgrave is a bit of an inconspicuous generated texture because you can do a lot with it, but when you place it down with the default values, there's not that much that's actually interesting about it. In fact, it doesn't look all that different from a Voronoi generated texture as well, with just a color ramp adjusting the black and white values. See that, I mean, we can adjust the scale, we can adjust the detail, but even then, if we look in, it's not really changing a whole lot. But there's a combination of values I like using, which is 2.7, 16, 0.16, and 1.41. So here we go. The results are a lot more interesting than they were originally. And we can make heavy use of this if we wanted to use it for, say, a roughness mask. And I can demonstrate this to you if I plug in the glossy BSDF and move it down to roughness instead of color. See, immediately just with one generated texture, we can already get this complex, altered, subtle surface imperfection effect. So if I zoom in and let Cycles render it up close, see, it's really not that bad. But we can do a lot more to increase the variety of this. Okay, so let's use a color ramp. Now I'm going to go back to using the emission shader so we can just see exactly what's happening with the mask. So the height range of the Musgrave texture is being fed into the color ramp here. And we can essentially change the influence of colors using the handles for the low to high height values. So as I scrub the black handle up, you can see that it's taking over more and more of our generated texture until we leave just a tiny bit of white at the top here. So we've just got these splatters of the highest height values essentially. And of course, if you know how to use a color ramp, you can change the colors, but because we're just using masks, I'm going to keep it at white for now. Another thing to keep in mind here is that if you zoom into the texture, you can see that it kind of fades off like a gradient from pure white down to black. So we'll have this mix of grays hidden away. If you change the easing type here from linear to constant, then you can see that it basically gets rid of this gradient. And if I move the black down and the white across, we have a perfect black to white transition. Understanding how these different interpolation modes work is key to getting some really interesting effects up close. Okay, so let's take a look at how to use more than one generated texture and combine them to create a more interesting mask, which will essentially give us a more interesting surface imperfection effect. So I'm going to duplicate our Musgrave and our color ramp. And what we're going to do is we're going to alter the Musgrave here so we end up with a result that's a different scale. So I'm going to set this to about 10.7. and change the detail down to 6. So we end up with some more blotches rather than high frequency details. So we can look back at our original one, that's a lot more detailed, and then our second one, which is less detailed. And we can take a look at how these will influence each other when we combine them with a Mix RGB node. So let's place down a Mix RGB node. And we're going to plug the first one into the color 1 value and the second one into the color 2 value, and then plug the result in here. Okay, so it'll be on the mix mode by default. And what mix does is, well, the factor value essentially acts as a balance between the two different textures. So a value of 0, it's going to be entirely the first texture, and at a value of 1, it's going to be entirely the second texture. So naturally at 0.5, it's going to be a mix of the two. It's a bit of a strange result. We don't really want to use the mixed value unless we have a very specific use case for it. But I'm going to show you, because these masks are made out of entirely black and white values, it means we can effectively use addition and subtraction, so basic math operators, to get interesting effects. So if I change this mode to add, what it's going to do, if I turn the value all the way up, is just add the white values of the second texture to the first texture. And we can see that as I scrub the value, they disappear and then they reappear. Likewise, we can also use subtract, which instead of adding, will remove the white areas. So if there's a white area on the first texture and a white overlapping area on the second texture, then it will subtract it and we'll end up with a black zone. And you can see that as I increase the factor, the blotches created from our second texture are actually cutting out of the original texture. And this gives us a much more interesting result, because we can kind of imagine this to be like, I don't know, melting or flaking paint or some other kind of weird adhesive material that's breaking off. So by experimenting and combining different generated textures with different parameters, you can essentially get an almost infinite variation of looks and results. And you can see that because it's all procedural, we can modify the values to change how the effect looks. Now, to see what this looks like on the surface, I can plug the color output of our subtract here into the roughness, plug the shader back in. And if we come out here, you can see that the roughness is now being affected by this mask. Now this material is quite shiny, so there's quite a harsh transition between the shiny low roughness areas and the high roughness areas defined by the mask. So something we can actually do here is use a math node, because when it comes to black and white values, you can actually perform quite simple operations on them without ruining any color data, because we only have to worry about 0s to 1 essentially. So I've added a math node here and the mode is set to add, and the color input is coming to the first value, and I'm going to plug the output value into the roughness. So by default, the value to add is 0.5, and you can see that what's happening is it's adding 0.5 to every pixel in the mask, pretty much. So all of those black pixels, which define low roughness, now have an extra 0.5 value added to them, which means that they will now represent a higher roughness area. So that's why it's become less shiny. And I can scrub this down again. So we're adding nothing, scrub it back up. So we're adding 0.6 now, 0.7, and you can keep going, but you'll eventually end up clipping out. So this just goes to show how useful it is to perform mathematical operations on these black and white masks. And now we're going to take a minute to talk about color. Now when it comes to color, we can actually define where color data is going to be placed on the surface. And we can do this by placing down another color ramp. And we're going to feed the output mask here into the factor input of the color ramp. Now one caveat here is that even though we can place any colors we want along this range, we have designed the mask in a way where there's essentially no range happening. There's no gradient because we're using the constant interpolation mode. So if I set this to ease for both of these, if you look carefully, you can see that there's more of a gradient of values here. So when this mask is plugged into this color ramp, we have essentially more space to play with color. So if I drop an extra handle down here in the middle, change this to something like green, and then I've got to make sure that I actually plug this into the color, then you can see how the mask is representing the color here. Now because we've got black at the end here, that's going to be black, so let me bring this up a bit. And just to demonstrate again, let me change this top ramp to like a bit of a darker blue. So you can imagine that as the gradient goes from low to high height, so from black to white, so too does the color on this color ramp. So imagine the left side is the black low values, and the right side is the white high values. So at the bottom we have pure white, which is just shiny here because, as you can see, we have the mask plugged in as the roughness as well, which is saying that this is going to be completely 0. So that's why it doesn't look completely white. But if I unplug this here, you will be able to see that it is actually just white. I'll plug it back in. And then as the ramp goes up and the height increases, then we pass through these different layers of color. So we go to green first, and then as we move along, we get to blue. So of course I can keep adding more colors and change something like this down here to sort of yellowy orange. So you can kind of imagine how you can get different layers of muck and dirt building up by using these masks. And also another use case scenario you can imagine is if you were building, say, procedural planets and you had different layers of terrain with different colors. This is a way you would do that as well. But for the sake of actually making this useful, I'm going to remove that and add some more sensible colors. Let's give that a bit of a gray. Make that white just slightly under again. I'm going to make the roughness about 0.28. So you can see here how with just a very few nodes and only using the Musgrave texture so far, we can create some very interesting surface imperfection effects. And by combining more than one generated texture, we can increase the variety of that effect by a significant amount. See here that if we have this subtract value at 0, it's just the original texture, very predictable, quite recognizable as well, because Musgrave at these values always tends to look something like this. But as we subtract the second texture, then it gives a lot more definition, like there's a bit more of a story of decay and some flaking away. So you can experiment with these values however you like, and the more you do it, the more you'll build up a mental library of what kind of combinations of nodes will produce which kinds of effects. And because it's all procedural, you can change all the values however you like. And if you come up with a combination you like, you can of course just turn it into a new node group. So say if I select all of these, press Ctrl and G, it's created a new group. Let me press the arrow at the top here. And here we go. We've essentially made a new kind of generated texture node, one that's personalized to our own design. So if we ever wanted to reuse this in another material, we could just copy, paste it, or append it from a different file, and then plug the values in. And of course, you can add your own inputs to customize the node as well. If we go in with the N menu, you can add your inputs here, but we can talk about that in another video. So this has been a simple example, but even though the principle behind it is very simple and we're only using a few nodes, you can get a large variety of results if you just play around with the values. Now, the reason I've been playing around with this recently is because I've been building my new node pack, which is about modular metals. And to go along with this video, I have uploaded some demonstration surface imperfection materials to my Patreon, so if you're interested, you can go and sign up to that. But also, if you want to dive deeper into building surface imperfections in Blender without necessarily using procedural nodes, then there is one add-on I want to recommend to you. It's called Smudgr Pro One-Click Photorealism, and the whole point of this add-on is essentially using grunge and dirt type textures to build up surface imperfections. When you install the add-on, there is a user interface that you can use to get one-click results on your objects and materials. And as you can see, the results are quite realistic. So if you're interested in using this for your more photorealistic scenes, then it's definitely worth checking out. There's quite a large variety of content in here as well, and it does make use of image textures instead of procedural nodes, so you know that it's based in some kind of grounding in real life. And yes, it does work with Blender 2.9. If you're interested in checking it out, then I will leave my affiliate link down in the description. So hopefully you found this interesting. If you do give this a try for yourself, then feel free to tag me in any results you make, because I'll be interested in seeing what you can come up with. So that's where we'll leave it for now. Don't forget to like and subscribe if you like destroying default cubes. So thanks for watching everyone, stay safe, and I will see you next time.